The electron configuration is the way the electrons are arranged within an atom. So you'll recall that electrons are negatively charged subatomic particles that are very, very small, and they orbit the nucleus in shells or clouds. And there's specific ways in which those clouds or shells are filled with electrons. So let's start by doing an example. I'm going to show you magnesium. So magnesium has got an atomic number of 12. So that means it is also 12 electrons. I want to show you how they can be arranged, and I'm going to do so by demonstrating using something called a Bohr diagram. A Bohr diagram is a way of representing the number of the electron configuration diagrammatically. Okay, so the way we do that is, first of all, we write the symbol for the element in the middle, and then we're going to draw the shells. So the innermost shell for any atom can only have a maximum of 2 electrons. So in a Bohr diagram, we draw the shells as circles and the electrons as little crosses like this. So magnesium has 2 electrons in the innermost shell. The second shell can have a maximum of 8 electrons. So that gives us a total of 10 electrons now, 2 and 8. So we need to then move out to a third electron shell. The third electron shell, we're going to have another 2 electrons. So this is a Bohr diagram for magnesium. It shows that there's 2 electrons in the innermost shell, 8 electrons in the second shell, another 2 electrons in the third shell. So there's some certain rules here for our electron configuration. Firstly, shells need to be completely filled before moving out to outer shells. The first shell can have a maximum of 2 electrons. The second shell or cloud, a maximum of 8 electrons. And the third shell also has a maximum of 8 electrons. Now, after that point, after the first 20 elements, things are a little bit more variable. So we're only going to be focusing on the first 20 elements, and this rule always applies up to that point. So I'm going to show you another Bohr diagram. I'm going to also show you another way of being able to represent this. That's a shorthand, if you like. So what we can do is just draw or write the electrons in each of the shells without drawing the diagram. So magnesium would be 2, 8, 2. So that's a very much an easier way of doing it. So let's go through and do a few more. So here's oxygen. Now, oxygen has an atomic number of 8, so that means that it's also got 8 electrons. So let's say oxygen in the innermost shell has a maximum of 2 electrons, and now it's full. So then we need to move out to the second electron shell. We've already got 2, we need 8, so therefore we've got 6 more. So that's oxygen. 2 and then 6, or shorthand would be 2, 6. I'm going to show you one more. Let's do sodium. And sodium, of course, has an atomic number of 11. Okay, so that's going to be quite similar to magnesium. Okay, so sodium. First shell, 2 electrons. Second shell, another 8 electrons. And then third shell, this time, so we've got 8 and 2 is 10. One more gives us 11. So the way we can express that is by going 2, 8, 1. And chlorine. So we'll do chlorine first. So symbol for chlorine is Cl. And the atomic number for chlorine is 17. Okay, so let's go ahead and do that. So Cl, 2 in the innermost shell, and then in the second shell we have another 8. So what does that give us so far? That gives us 10, and we need 17. So in the third shell we're going to have another 7. And that's chlorine. Or an abbreviated version would be 2, 8, 7. Okay, so now I just wanted to show you calcium, which is the 20th element. Let's go do calcium. Okay, so calcium, it's the 20th element, so therefore it's got an atomic number of 20, and it's got 20 electrons. Okay, so here we go. So calcium, inner shell, 2 electrons. Second shell, 8 electrons. Third shell, so we've got 2 and 8 so far. So 2 and 8 is 10. So we need to fill this third shell. So 2 plus 8 is 10, plus 8 is 18. So we need to go to a fourth shell and have 2 electrons in the fourth shell. And that's calcium. So we go 2, 8, 8, 2. So 2 ways of being able to express the electron configuration.